This is Professor Jimenez, and this is practice number 1 for assembly code. So here we have the PIC microcontroller 16F1619, which will be configured with ports A and port B as inputs, and port C will be configured as an output. So and we will use port A to input the data bits given by this deep switch with 6 positions or 6 bits that we will be assigning, and it contains also a pull-up resistor network RM1 made of 10K each, to which work as a pull-up resistors to avoid having port A from floating. RC0 through RC7 configures and outputs are connected directly to this LED bar graph, and with its respective series resistors of 220 ohms to protect them. So knowing that now we have this schematic, and we will do a code to keep reading port A and transferring this data into port C from RC0 to RC5, because we don't have more data from port A. So to work with the code, we will get into the app Microcode Studio, and we will open the file CS281 practice 1, this one. Okay, so in this practice I'm going to show you the first, when you have here the assembler code. First you have to select the new right here, so you can start writing the code. Because of the amount of time limited that I have in these videos, I wrote the code and now I'm going to explain it. Otherwise it will take me more than half an hour. To write the code here, first we start with this pre-assigned format or form, where you get the green letters and you just write text and references for your file. Then you configure fuses. This is a configuration memory space in the PIC Micro, where you configure the internal oscillator, power time enable on, power reset, and then the master clear off, and other bits like a brownout reset on, so if the battery goes less than 3 volts, it'll be reset, and many other features. We will see all these configurations in another video lesson. So to start writing in assembler code, once we finish the configuration, we give the command end configuration. Then we start writing in assembler code. Right here I have this space because sometimes you decide to create some variables of different types of variables. But now we will focus on this code. So just a second. Okay. First, you have to start writing by typing here ASM, which it's indicating that you will be working in assembler code. And move LB, this one selects bank 1, because move LB you give the page the bank that you want to select. Even when it is given in hexadecimal, you can write it in decimal. And remember, there are 32 banks of memory So we're going to bank 1 because that's where we have to work with the working register, move all W. So we assign this value, this digital value, we assign it to W. So we transfer this constant to W, and then we move W to the OSCON, to the file OSCON. That way the OSCON is configured with this constant. 6, this is 6, and this is 10 or A in decimal. So to set the internal oscillator to 4 megahertz. If we don't do that, it'll be working at 16 megahertz by default. And then we clear the OSTUN, or we make OSTUN equal to 0. So we rest assured that we are working at 4 megahertz. Now the move LB 00 hexadecimal, now we return to bank 0, because in bank 0 is where we have all these ports. So we clear port A, then we clear port B, clear file port B, and we clear port C. So we make sure all the 3 ports are cleared. Now we have to configure the ports. So we have to go to bank 1, because on bank 1 we have to select the bank 1 by with the instruction move LB is 01 hexadecimal, and now we can we move a literal to W. So we store this number, hexadecimal number FF, or equal to all ones. We move it to W. So W is loaded with this binary code. Now that we have this binary code, we move that number FF, we move the number, the constant or literal F, to file tristate. We also make a copy of that constant, of that literal, to tris B, and so because tris A, tris and tris B are filled with all ones, we make both ports equal to inputs. If we clear the contents of tris C, port C will be an output. So the ports are now configured, but the ports by default are analog, so we have to set them as digital. So we have to go to bank 3, because in bank 3 is where we have the AND cells. So first we clear move LW0, or we clear W, and then we transfer 0 to AND cell A, we transfer 0 to AND cell B, and we transfer 0 to AND cell C, so all ports are digital. Another way to do this is by just clear F AND cell A, AND cell B, and clear F AND cell C. So that's another way to do that. So that'll be, as I said, clear. Let me put them in capitals. Clear file B. That's another way. Okay, clear file AND cell B. That'll be another way to write it. So, and to disable the pull-up resistors that are contained on each port, we do this bit set file option reg bit 7. So bit 7 from this register is made equal to 1. That way all pull-ups are disabled. And now we select bank 0 again by doing the move LB 00 hexadecimal, and we put here a label called X to mark the label where I want to go back with my software. So now here I do this. I select, let me amplify this. I select move, I do the instructions move file port A, 0. So read port A and transfer the contents of port A to W. Then move WF port C. Now the contents of W are transferred to port C. So I'm reading port A. It has to go to W, the working register, and from the working register to port C. Then I leave here an NOP instruction for 1 microsecond pause, and which is optional. And then I go back to X, so I go back here. So the micro will stay here in this endless loop, because it'll be updating the reading. So if you don't change the data, the LEDs will be on with the data on port C, with the data that was read on port A. So this is a very basic program where we are demonstrating that we can read the contents of port A and transfer those contents to W, and from the working register to port C. Of course, there will be other programs where we will make other things with these contents, and this is the first code. And every time you finish a program, you have to write an end, and then the end assembler to indicate that we are ending the assembler code. Okay, so that's it for this small program, and we will see other ones later. Thank you.